The order of operations in mathematics. First of all, let's think about what an operation is in mathematics. It's something like addition, subtraction, multiplication, division. Those are the basics we think of, but it can also be raising something to a power. It could be some sort of grouping like the square root, or a numerator and denominator. It could be something like parentheses. Parentheses sometimes show up as square brackets, sometimes as curly brackets. All of these things and more mean something in mathematics. So if I'm faced with a problem like 3 squared minus 5 times 2 plus 1/5 divided by 3 times 2, I may just decide to go make a cup of tea. However, there must be some way that we can all get the same answer, and that is done through this idea of ordering the operations. We decide which one we're going to do first, which one we're going to do second, third, fourth, etc. In this particular case, we don't have any grouping or parentheses, and we've got what? We've got an exponent right here. That was one of them up here. We have a subtraction, we have multiplication, we have addition, and we have division. We've got another multiplication at the end. So we come up with a convention that says what we're going to do is we're going to do exponents first before we do multiplication and division, and then we're going to do all the multiplications and divisions and then do the addition and subtraction. Now we've already seen that multiplication and division are commutative. We've also seen the same thing with addition and subtraction, meaning that for each one of these it doesn't matter what order we do it. 2 times 3 is the same as 3 times 2. We write it this way, and I'll tell you why in a second, but it really is just multiplication and divisions as a whole group, all of those multiplications and divisions, then all of the addition and subtractions, and both of these are done left to right. To remember this, we say, "Excuse, my dear Aunt Sally." And you can see the E for exponent, M for multiplication, D for division, A for addition, S for subtraction. And that helps us remember which one comes first, which one comes second. So let's go ahead and do this problem. Let me rewrite it. Alright, so the first thing we're going to do is this exponent. Notice this is an expression. There are no equal signs, no equal sign. So I'm just going to drop down one line to do each operation. So the first one is going to be the power, this exponent 2. So 3 raised to the second power is 9. And then I'll just recopy this down. We may be tempted at this point to say 9 minus 5 is 4. However, we've got a multiplication. That has to come first. I should say that has to come before the subtraction. So I'm going to do this multiplication, and I've also noticed I have a division in here between these two numbers. So I'm going to do these two before I do the addition and subtraction. So I've got 9 minus 5 times 2 is 10, plus 1/5 divided by 3. How did we do that? Well, let's do that over Let's just do that over here. Remember, it was 1/5. We changed this into a multiplication, and it was multiplied by the multiplicative inverse of 3 or its reciprocal, right? So that's the same idea. So this becomes 1/15 minus 2. Did I change this? I did. I'm terribly sorry. This should be multiplication as well. So we did this one, and then we're going to go left to right. So we did the first one, and now we're going to multiply it by 2. So I'll do that here. 9 minus 10 plus, and this will be 2/15. Now I'm going to do the addition and subtraction left to right. So addition and subtraction is all that's left. So I'll say 9 minus 10 is minus 1 plus 2/15. But minus 1 is the same as minus 15 over 15 plus 2/15. So this is what? Minus 13 over 15. Had I done a different order of operations, I may not have gotten the same answer. For instance, had I taken and subtracted these two, which would have been wrong, right? I would not have gotten the same answer. So we don't want to do that. Stay with the order of operations. Now sometimes we want to force something to be done. So to force an operation, what we do is we add parentheses. Or grouping. And this is where you get the traditional "please excuse my dear Aunt Sally," even though we all know Uncle Bob did it. So let's look at another example here. 5 minus 2. And I'm going to group this 6 minus 8 squared. Now the exponent is what we did first last time. However, in this case it gets a little messy because we've got 6 minus 8, and I'm not really sure how to raise that. How do we square that? How do we multiply that? But parentheses or grouping, P, please, comes first. So I'm not going to worry about this 5 minus 2. This is a very common error. A lot of people will take this 5 minus 2 and call it 3, right? And that's completely incorrect. Do you know why? Well, if you look at PEMDAS up here, the subtraction is at the very, very end. It's the very last thing we do. So we don't want to do it first. So I'm just going to carry this down. We'll do the parentheses first. Math sort of goes inside out, right? So we go into the parentheses, say this is a minus 2. 6 minus 8 is minus 2, and I square it. Now there's nothing really I can do in this minus 2, or within the parentheses. It's minus 2. It's going to stay that way. I'm going to leave it in parentheses because remember last time we looked at raising something to a power, it was important if I have a negation in there to know whether I'm raising 2 or minus 2 to the power. So we'll go ahead and do that. So minus 2. This is a multiplication sitting right in between those. So I'm going to leave it as a multiplication by keeping the parentheses. But minus 2 squared is the same as minus 2 times minus 2. Two negatives multiplied together. That's right, is positive. So remember there's a multiplication sitting in right in between these two. Sorry about the writing. So this is 5, so I'm going to do the multiplication first. It looks like I want to keep making that a 3, but I don't. So 5 minus, what's a minus 2 times a 4? Minus 8. So 5 minus 8. So that leaves me with minus 3. Now perhaps you noticed that at this point I said, what's a minus 2 times 4? So I was picking up my term, in this case, to be minus 2. So in my head, I was putting basically an addition here. Right, and we've learned how to do that. So I can say minus 2 times 4 gives me minus 8. So this is 5 plus a minus 8. It's just another way of doing it. Let's try one more. I'll do this one fairly quickly. 5 minus 3, 12 minus 8, all over. 5 plus 2 times 6 minus 3 cubed. And the point I want to make here is the numerator and the denominator are groupings. And this means these are essentially parentheses. They're the P of please excuse my dear Aunt Sally. So I'm going to do the operations in the numerator completely, and then do the operations in the denominator completely. So let's do that. So I have 5 minus 3, 12 minus 8 is 4. Now in the denominator, I'll just rewrite it for now. And I think we can do this in our head. 5 minus, well, what's minus 3 times 4? It's minus 12. So that would be 5 minus 12. 5 minus 12 would be minus 7. And now we've got the numerator done, so let's look at the denominator. 5 plus 2 times 6 minus 3 cubed. Here I'm going to do the 3 cubed first, so I'll just keep that minus 7 going. So 2 times 6 minus 3 cubed. 3 times 3 is 9, times 3 is 27. Minus 7. Now which one do I do first? That's right, multiplication. 2 times 6 is plus 12, minus 27. Now I'm going to bring my work up here for a second. So this becomes minus 7. 5 plus 12 is 17, minus 27. So I get minus 7 over minus 10. But in division, if the signs are the same, I get a positive answer, so it's 7/10. All right, very good.